my name is Jason Music, and I'm an engineering student at the University of Maryland College Park. This video is serving as my final video for my remote sensing class. You're probably wondering why I started off this video with a quote from Lord Acton that states, "History is not a burden on the memory, but an illumination of the soul." But what exactly does this mean to me? Well, there's conflicts within our society where there's memorials and statues and symbols being removed due to their dark ties to the past. Today's youth won't be able to appreciate that later in life. So I decided to scan a memorial on campus, the Vietnam Memorial, in fact. Let's go ahead and take a video, and I'll show you my progressions through this project. Thanks.
So one day I was walking across campus and I was at the south side of the chapel, and I saw this little slate path. Decided to walk up it one day just to see where it would go, and I saw these two benches with a plaque in the center. This is the Vietnam Memorial that I chose at the University of Maryland College Park. You can see two benches with the memorial plaque in the center. Ultimately, this is what I printed after doing my 3D scan. This shows me working through the first steps of this project, going through some coding. And then here I use the coding to do a calibration check so I can judge distance correctly using my LiDAR system. Here's a close-up of my tripod LiDAR system. Notice I have two legs facing forward, which would make a straight line. This made it easier to keep the laser perpendicular to my target. Here's the top of the LiDAR system. Starting from the right side, we have the Raspberry Pi with the camera in a case. All that has a USB connected to an Arduino going to the Raspberry Pi with an accelerometer attached to the Arduino. The Raspberry Pi is powered through a mobile battery source, which is the black box in the back. The black cylinder object is a 5 milliwatt laser, green laser, that would point to the target. I have all that clamped down with clamps, and I especially made a bracket to make sure that the laser was in line in the same plane as a Raspberry Pi camera. Also, you may note on the left side of the wood you'll see little tick marks. Each mark is a ½ inch distance. If I remove the clamp, I can move the laser to the left, which will allow for greater accuracy at further distance. Lastly, I'm able to control the Raspberry Pi using a Cat5 cable connected to my laptop. I VNC'd in and was able to remotely control the Raspberry Pi. Now let's take it out to the field and see what it does.
If you notice in that last video, it was dark, and I only did one vertical scan, did one scan down, and followed it back up, one path. But in order for you to see exactly what I was doing, I did another video during the day so you could see exactly how I was able to move the rig and do a 3D scan from left side of the memorial all the way to the right side. Take a look at it.
Hello, this is Jason Music doing my LiDAR scan of the Vietnam Memorial at University of Maryland College Park, the chapel. Currently there's my laptop hooked up via Cat5 to my rig, which is going to scan the two benches and the memorial in the center. And you can see I have measuring tape across the bottom to try to make good scans. So let's go ahead and see what happens. Alright, system's running, and we will go ahead and start scanning slowly but surely. Sorry, had to turn off my laser. Alright, so now we'll take and move over 6 inches to roughly about there, and then we'll turn our laser back on. And continue to scan. Nice and slow, or at least trying to anyways. Alright, get to the top here and let's see what this gets us. Thanks for watching. Bye.
So as you can see in the video, I scanned down, moved over 6 inches, scanned up. I continued that process until I hit the right side of the memorial. The whole time that this was happening, the Raspberry Pi was collecting data and putting it into a text file. From that point, I was able to take that text file and import it into a MATLAB code. From there, ran the code, and MATLAB was able to produce a 3D point cloud. Afterwards, I was able to take that 3D point cloud, and again, using MATLAB, made it into a file that MeshLab could understand. After that, I imported that file into MeshLab and was able to produce a surface region for that 3D point cloud. The following next couple of pictures will dictate that whole process in sequential order, going from 3D point cloud to a mesh surface. Take a look at it. After I was able to successfully take the 3D point cloud and make a form in MeshLab, I then took that part and imported it into a CAD software. I specifically used Creo. From there, I was able to design a base and put some words onto the base and put it all together, give the monument a thickness, and from there I was able to perform a 3D print. Take a look at it. Thanks. Overall, this was a fun project. As you can see from the video, I was able to 3D print. In fact, this is kind of what it looks like. You kind of see all little angles and whatnot. I had a blast doing this project. In fact, I'm going to keep my system and toy around with it and see what else I can scan and then put into my 3D printer. Thanks for watching, guys. Bye.